All right, guys, here we go. We're getting pretty close to implicit differentiation and related rates. And I guess we're almost there because now we're talking about different rates of change. Uh, but yeah, we'll start with the most common ones. And I think we'll start with the ones you already know, and we'll do a formal definition today. So so here we go, guys. It says the instantaneous rate of change of f with respect to x at a is the derivative. So you guys already know that. And then it says find the rate of change of area of a circle with respect to its radius r. So that means that this circle is changing with respect to r. So imagine a circle starting at, I don't know, starting at a radius of like 1 and increasing until you get like a radius of 5. So that's all they're doing. So do you know the equation of a circle? In the area equation of a circle. Now it's not 2 pi r squared. So if the radius is increasing at a certain rate, so let's see, find the rate of change of the area r. So I'm taking the derivative of area with respect to r. So that's how you write it, dAdr. You can also think of dAdr as the change in area over the change in radius, right? dAdr equals, so take a guess. What do you think the derivative of pi r squared is? 2 pi r. And yes, you can probably say dr, but dr is just 1, so there it is. And that's it. Cool or not cool? Simple, nothing crazy, right? Yeah, that's it. And it says evaluate the rate of change of A at r equals 5 and r equals 10. So here's how you do it, guys. The notation is dAdr evaluated. That's what that line stands for. Some of you already know that if you're in computer science. Evaluated at r equals 5 equals, you're just going to go 2 times pi times 5, and you get a 10 pi. And what are my units? Do you guys know what the units are? What are the units for area? Well, let me see. They don't tell you here. Let's say they're inches. What are the units for area and what are the units for radius? Yeah, square inches per inch. Do not cancel out any of the units. DADR, and I was influenced by what I saw on the bottom. It said inches there. DADR when R equals 10 equals 2 pi times 10, so 20 pi square inches per inch of radius. And that's what letter C says. If R is measured in inches and A is measured in square inches, what units would be appropriate for DADR? Square inches per inch of radius. Square inches per inch of radius. Do not cancel out the units. And that's it. What do you guys think? Not bad? Pretty straightforward? All right. Instantaneous velocity is the derivative of the position function. Sometimes they call the position function s. Sometimes they call it x if it's motion on the x-axis. Sometimes they call it y if it's motion on the y-axis. We're in Cal 1, single variable. So you're either going to do motion left to right to left. You're either moving horizontally or you're moving up and down. And that's it. When you get to multivariable calculus, you do 2-dimensional and 3-dimensional, x, y, and z. For now, we're just here. We're not going to do any cross product or dot product. For those of you that have heard of cross and dot, have you guys ever heard of that? No? Okay, then don't worry about it then. Yeah, we'll wait for your differential equations or your discrete, your whoever your professor is in matrices to learn about all that good stuff, or multivariable if you reach it. Okay, so the derivative of position is velocity. Let's do that one more time. Derivative of position is velocity. Perfect. That's all it means. So look, here's my position. I took the derivative, and it means velocity. That is super important. I can't stress enough how important this is. On the AP exam, when I was a reader for one of the questions, that was literally a point. And if you did not write that you got the velocity from taking the derivative of position, guess what? They did not give you the point. So notation is important. Notation. They tell you what speed is. Speed is the absolute value of velocity. I think you guys already know that from physics, but just in case. And then check it out. Acceleration is a derivative of velocity, which is the second derivative of position. Do you guys see that? So the derivative of velocity is acceleration. Take a guess. What do you think the derivative of acceleration is called? You've seen it in shirts. It starts with the letter J. It's called a jerk. So if you want to be mean to, if you want to call your boy or your girl a jerk, you say you're being a derivative of acceleration. The derivative of acceleration is called a jerk. So now you'll know. Now if you Google, you'll understand those nerd jokes. English units, 32 feet per second per second. And metric units, 9.8 meters per second. They both mean the same thing. It just depends what units you're in. Cool or not cool? All right, I think we know enough. Let's see if we can figure this stuff out. We're going to go slow. We're going to go really slow. Do you guys have a calculator? We may need one. So check it out. Now you can do questions like this. A dynamite blast propels a heavy rock straight up with a launch velocity of 160 feet per second. That's your initial velocity. It reaches a height, so here it is. So it's moving up or down. It reaches a height of this. That 160 feet per second, that's that 160. Velocity initial times time. Where did that 16 come from? Half of 32. The gravity is the acceleration due to gravity is 32 feet per second, and half of 32 is 16. So these equations come from somewhere, guys. I don't want you to think that they just came from nowhere. Where did this equation come from? Velocity initial times time plus 1/2 at squared. Do you guys remember that one? There it is. That's where it came from. Acceleration was 32, negative because it's going down, the acceleration, and velocity initial was positive. So there it is. 160t minus half of 32, 16t squared. So it came from somewhere, guys. Cool or not cool? How high did the rock go? Okay, I'm not going to throw this pen up because I might break it. Pretend this is a rock. Here comes the blast. How do I calculate how high this pen goes? I need to know what. What happens at the very top? No, the acceleration is always constant. What's the velocity at the highest? 0, right? Look, this is a rock. It goes up. At the highest moment, the velocity is 0. Yay or nay? So here's the game plan. I'm going to find when the velocity is 0. And then once I find when the velocity is 0, I don't know why I'm doing this with my hands. I apologize. Once I find when the velocity is 0, I'm going to plug in that time into my position equation. Does that make sense? All right, so here we go. I'm going to write S equals 160t minus 16t squared. And I need to find my velocity equation. I find velocity by taking a what from position? Derivative. So I'm going to write v equals ds dt. So I'm showing that I took the derivative of this. What's the derivative of 160t? 160. I'm taking it with respect to t. Minus, what's the derivative of 16t squared? Perfect. I'm going to equal this sucker to what? 0. I'm going to solve for it. So I'm going to go 32t equals 160. I'm going to divide by 32, both sides. And I want to say that the answer is 5, but check for me anyways. 160 divided by 32. 160 divided by 32. 5. Are we okay? Now that I know, I haven't answered the question yet, guys. Now that I know that the time is 5, I plot this back in here to see how high this went. Because this is a model that tells me how high the rock goes. So I'm going to write S of 5 equals 160 times 5 minus 16 times 5 squared. So I take my calculator and I'm going to go 160 times 5 minus, did I say minus 16 times 5 squared? Minus 16 times 5 squared. I don't have to put the parenthesis there, but I did. I got 400. So the highest it goes is 400, what are my units? Feet. 400 feet in the air. Is everyone okay? Nothing crazy, right? Okay. Ask me questions, guys, because I can't tell by looking at y'all's faces. What is the velocity and speed of the rock when it is 256 feet above the ground on the way up and on the way down? All right, find the time values. So here it is. I'm going to write 160t minus 16t squared equals 256. Do you guys know why I did that? Be honest. This is my position equation. I need to figure out the time values when you're at 256 going up and when you're 256 going down. So I need to figure out when I'm at position 256. Cool or not cool? So that's why I set up the S of t equal to 256. Did I answer everyone's question? Okay, I'm going to move. Let's see, what am I going to do? I'm going to move everything to the right, and it looks like I can factor out a 16 out of everything. So I'm going to write 0 equals 16t squared minus 160t plus 256. I'm going to factor out a 16. I'm going to have t squared minus 10t plus 16 close. I think 16 times 16 is 256. Yes or no? No? Yes. Okay. I was about to try it out. Oh. 256 divided by 16. 16. Curve. Perfect. All right. Here we go. Two numbers. I think we could use a calculator, but it's an easy number. Two numbers that when you multiply give you 16, add up to 10. T minus 8, t minus 2. Remember, this equals 0. So my two t values are 2 and 8. Take a guess. Which one is going on the way up? Which one is on the way down? At 2's on the way up and at 8's on the way down. So if I find the velocity, you should not be shocked that at 2 seconds I'm going to get a positive value, and at 8 seconds I'm going to get a negative value, because that positive means going up, negative means going down. Yay or nay? Okay, here we go. My velocity at 2 equals, and I just need my velocity equation, here it is, 160 minus 32 times 2. So let's see. I take my calculator, and I'm going to go 160 minus 32 times 2, and 96. And it's symmetrical, so I'm assuming the next one is also going to be 96, but on the way down. So velocity at 8, 160 minus 32 times 8. It better be the same number because this is symmetric. I started at the ground. So I'm going to go 160 minus 32 times 8. Negative 96. Now, if I would have dropped it from a building, if I would have shot it up and then brought it down, it would have gotten different numbers. Because, I'm going to the ground from the building and all that. If I don't make sense right now, don't worry about it. All right. Are we okay right now with that right there, guys? Are we shocked? Don't worry, I see you. Are we shocked? Okay. What's up, miss? We took a derivative of position. Derivative of position is velocity. And that's my velocity equation from right here. Right here, look. Of position. My S is position, yes. It tells you here. It reaches a height, so this is telling me what height I'm at. You know what I mean? Yeah, good. Good questions. All right. Guys, without even doing any math, it says, what is the acceleration of the rocket any time t during its flight? You're on Earth. So what do you think the acceleration should be all the time? 32 feet per second per second. If I'm giving it direction, negative 32 feet per second per second. So I take my velocity. What was my velocity equation? It was 160 minus 32t. And here it is. Acceleration with respect to time equals dv dt. I'm showing that I'm taking the derivative. And I got negative 32. Are you shocked? No, you should not be shocked. It's negative 32 feet per second all the time. Always. For any time t. Cool or not cool? All right, last one. And guys, you know what? We'll even do a hack. You know what? Let's not do a hack yet. Because we're not ready for it yet. All right. When does a rock hit the ground? Do you have, all right, guys, focus. Do you have a position equation? Yes, the position equation was, and I already forgot it, 160t minus 16t squared. This tells you where you are at any time t, guys. So when do I hit the ground? Whenever my position of this rock is at what? 0. Equal that sucker to 0 and then solve for t. Look, I have a t on both sides. I can factor out a 16. There's my 16t factored out. And I'm going to get 10 minus t. So what makes this true? Well, it's true if t equals 0. That's right when the blast happens. What's the other one? When t equals 10. Are you shocked that it was in the air for 10 seconds? No. How long did it take for it to reach the highest? How long did it take for it to reach the highest? 5. So it takes another 5 seconds for it to reach back to the ground. Does that make sense, guys? See? So there it is. There's your hack. You could have explained it that way too. Cool or not cool? That's all you do. That's all you do. And those are the basics. That's it. Cool or not cool? Let's keep going. Let's go to example 3. We're going to go slow, guys. So let's see if we understand what's going on. A particle moves along a line, so that's position at any time t greater than 0 is given by the function. Okay, so here's my function. I'm moving on a line, so I'm either moving left or right. So I'm gonna write that down. Moving left or right. They don't tell me how the line is. It could be moving up or down, but I'm gonna say left or right. Where S is measured in meters and t is measured in seconds. Are we okay so far? All right. Find the displacement of the particle during the first 2 seconds. Well, guys, look, this tells me where I'm at. So all I got to do to find the displacement, I just got to go position at 2 minus position at 0. That's all I got to do, guys. See, hopefully all this is just simple stuff reminiscent from your physics 1 days. S of 0. S of 0 is 0 squared minus 4 times 0 plus 3. I'm not making fun of you. I know that you can probably do this in your head, but just put it in there so you can see where I'm getting the values from. S of 2. 2 squared minus 4 times 2 plus 3. Let's see. 2 squared is 4. 4 times 2 is 8. And 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. Make sure that I didn't do any mistake. Here we go. Negative 1 minus 3. My displacement is negative 4. I moved 4 to the left from my initial position. Are we okay? Find the average velocity of the particle during the first 4 seconds. Okay, here we go. Average velocity. Average, it says average. Average velocity is going to be equal to S of 4 minus S of 0, my displacement, divided by 4 minus 0. Times the change in time. I haven't done anything crazy, guys. S of 0 is 3. S of 4 is 4 squared minus 4 times 4. Oh, it's going to be 3 again. Plus 3. 3 minus 3 over 4. The average velocity is 0. And I need units. Do they give me units? Meters per second. I guess when it's 0, it could be anything. Miles per hour, kilometers per second, because 0 is 0, period. Have I done anything crazy, guys? Please ask, because I cannot read minds. Ortiz, are we okay? For sure. Okay. Soldier boy, we're okay? All right. Here we go. Sorry. Yes, ask. No, because it does not ask for instantaneous velocity. It asks for average. That's a good question. Guys, why did we not take a derivative for B? It says average velocity. Highlight average velocity or underline it or whatever, however you take notes. It's not instantaneous velocity. Look at letter C. Find the instantaneous velocity of the particle when t equals 4. Now am I taking a derivative? Yes, I'm going to write velocity, which equals the derivative of position. Maybe, I don't know, maybe if the professor is looking at my notes right now, maybe they prefer for me to write dSdt equals v. It doesn't matter. There it is. And I'm going to take the derivative. What's the derivative of t squared with respect to t? 2t. What's the derivative of 4t? 4. And the derivative of 3 is 0. So there it is. I'm going to go v of 4 equals 2 times 4 minus 4. 2 times 4 is 8. 8 minus 4 is 4. So my velocity when t equals 4 is 4 meters per second. Put units when applicable. Are we okay so far, guys? Okay. Find the acceleration of the particle when t equals 4. How do I find acceleration? Take a what? Derivative of which one? Velocity. So a of t equals dv dt, which equals, what's the derivative of 2t? 2. It is always 2. I need units. Meters per second, or meters per second squared. Meters per second, I think is better. Soldier boy, you all right? Okay. All right, last one. At what value of t does the particle change directions? Guys, focus. If velocity is positive, I'm moving to the right. If velocity is negative, I'm moving to the left. So what has to happen for the velocity to change? What has to happen for me to change directions? Dang it. Almost gave the answer away. No. The velocity has to what? Equals 0. You're almost there. Change. Velocity has to change, and it starts with an S. Signs. If the velocity has to change signs, if velocity is positive, you're moving to the right. If velocity is negative, you're moving to the left. You cannot just equal 0. It has to change signs. So let's find where that happens. V of t equals 2t minus 4. And I'm going to equal this. Well, I guess, you know what? It's probably better if I graph it. V t. It starts at negative 4. Here's negative 4. Point. Where is that? I can figure it out. We can figure it out. When I cross the t-axis, or x-axis if you want to call it that, my velocity is 0. Do you guys see that? So I'm going to go 2t minus 4 equals 0. 2t equals 4. I move the 4 to the other side. I'm going to divide both sides by t equals 2. And then I make a statement. It doesn't have to be a crazy statement, guys. All you're doing is just stating the facts. You're going to go particle changes direction at t equals 2 since velocity, since what happens to velocity? Changes what? Perfect. Changes signs at t equals 2. And I know, you're saying it again. Sounds kind of funny. Say it again. Particle changes direction at t equals 2 since velocity changes signs at t equals 2. Done. How do you feel? Are we getting better? Oh, look, we're done. Is that it? All right, you're done, guys. So what I would do, I didn't put any deltas because we're not at that level yet. This one is going to eventually be a UH quiz. Relax. For those of you that are ambitious, it's called UH quiz rates. You have not had enough experience. You can probably get through about halfway. If you watch my video, you'll probably be able to get through all of it, but you have not had enough experience. What I would do is I would try some of those problems. You don't have to do them all, guys. There's 10 of them in there. I would just try like maybe 3 or 4, maybe half, just to make sure that you understand what's up. Cool or not cool? And then that's it. Take care of your UH quiz. Which one do we have now? We have 16. When does it due? On Tuesday, the next week. When do we have our 9 weeks exam? Tuesday. So make sure you guys know 9 weeks exam Tuesday.